Hello everyone, this is Kian. Thanks for joining us today. We're very excited to introduce BOSS to you, so I'll just get right into it. BlackRock Offline Sorter is an easy to use yet powerful software for viewing and classifying spikes or previously recording action potential waveforms from high impedance electrodes. So currently there are several offline sorting packages available to researchers, including ClusterQuick, POS, or Plexon Offline Sorter, Spike Sorter, mClust, Clusters, and so on. With the exception of POS, the rest are open source and they're available free of charge. The major complaints of these open source packages is that they're not very easy to use. Typically, the installation requires an advanced computer user who knows how to use Python or how to compile source code. And then even when that's done, then in most cases the interface isn't very user friendly, and of course there's no support. So you hit some sort of problem, you're on your own. The Plexon Offline Sorter is the only commercially available package that's easy to install, but it's still very hard to navigate, has too many options and features, and often people complain that it's too slow and very bloated with just too many options. So BlackRock is trying to solve this problem by providing a powerful yet intuitive and easy to use software package. The idea is that the user will be able to open the software, load a file, and without having to read a lengthy manual, they can just go through processing the data and easily sort their spikes. Spike sorting, as you may agree, should not take as much time as it currently does. The process has to be very intuitive, so you can spend more time on designing the experiment and also analyzing the collected data. Here I'm going to post a poll on time that it takes to process an hour of recording. Please take a moment to respond to this poll. Another part of the philosophy is that we wanted to design BOSS to be expandable, so we'll be able to easily add more file formats, increase the number of supported algorithms over time, and more features. Now, how do we follow our philosophy? We took in a lot of feedback from many of you on how best we can come up with a very intuitive and easy to use package. The software has gone through many iterations to be intuitive, and we're not planning on stopping here. So if you have any ideas, please do let us know. Additionally, we spent a lot of time on coming up with a very smart way to read extremely large files very quickly. The software works in the background to chip away at the file while you do your spike sorting in the foreground. Even better, the second time you open the file, everything just loads much faster than the first time. Another customization we included in the software package is the flexible layout that allows you to place the windows in and around the screen that helps you to be most efficient in your sorting adventures. So if you have multiple monitors, you can put different windows on different monitors or put them all right next to each other. Moreover, BOSS only displays the options that are relevant at the time. It won't overwhelm you with information and useless windows and features. For example, during the spike sorting detection phase, where you set filter values, the sorting options are not there. And when you sort and interact with the waveforms, the filter options are hidden. And finally, your sessions get saved automatically each time, so you can just continue where you left off the previous time. You'll see how great of a feature this is once you start playing around with it. Now my colleague Nick will give you a tour of the software and its features. Feel free to ask questions in the webinar platform, and we'll try to respond to them as quickly as we can.
Great. Thank you, Kian. So before we jump into actually using the software in our live demonstration, I just want to let you know that you can download a demo version of the software from our website, www.blackrockmicro.com/boss. But otherwise, let's go ahead and get started. So when you first open BOSS, you'll be presented with a screen like this. So just a normal file dialog that allows you to select the file that you want to load for spike sorting. In this case, I'm going to load an NS5 file, or as for those of you familiar with our file formats, a 30 kilosample per second continuous data file. And I'm going to choose a pretty large one here, just to demonstrate some of the speed that BOSS has when dealing with large files that Kian mentioned earlier. So if I go ahead in here and click Open, it asks me whether I want to continue the previous analysis session for this file. As Keon mentioned, anytime we edit or work on a file, BOSS saves our progress. So I could start right back where I left off before. But I'm going to go ahead and say no here so that we can start fresh. So when you first launch BOSS, you'll be presented with a screen like this. And before we jump into kind of using BOSS, I just want to give you a tour of some of the features that Keon talked about earlier and demonstrate how we can manipulate some of these windows to fit our workspace to be how we like it. So first off, some windows that you'll always have available to you. One of them is the channels window. So the channels window has a lot of information such as frequency cutoffs and filters used, a number of waveforms detected, number of samples, all sorts of information about a given channel. And you use this same window to select the channel that you want to work on in your recording. Another window that you can see changing at the bottom is our timeline view. So the timeline view is a time series of our data. So since we're working with continuous data here, this is just our 30K continuous data stream. And then finally, another window we'll always have available to us is actually this options window, which was hidden away over here. The options window will have information related to that step of the spike sorting process. So in this case, if we look in the upper left, we can see that we're in the detection step. And so it only shows us features that are relevant to detecting waveforms. Another thing to look at is the windows that we won't always have available to us, or the ones that are also specific to this step of sorting. These are the peak height histogram and frequency spectrum, which are kind of nested on top of each other. With any window, you can always break that window out and move it around. I could have these be side by side, for example, which is actually how I like them here. Or you can move them to separate monitors or whatever you like. So with that kind of workflow of BOSS out of the way, and demonstration of how easily flexible the layout is and how quickly we can load data from large files, let's go ahead and jump into the actual options window and working through this detection step.
So again, we're in the detection step, which means we need to be extracting spikes. And since spikes are high-frequency events, one of the first things we will always typically need to do is apply a high-pass filter to our data. So the high-pass filter is enabled by default, which is why my spikes look high-passed already in my continuous data down on the timeline. And you have a few different options here after selecting high-pass filter. First off, you can choose your filter type. I'm using simulated data, which is why it's so artificial but beautiful looking. So pretty much any of these filters will work for me. But when you're using your own data, you might have a certain reason for choosing one of these other options. For now, I'll stick with Butterworth, since this is the kind of default filter on the neural signal processor, and something this data would have been processed with. The other two options with our high-pass filter are cutoff frequency and filter order. Filter order is essentially the steepness of your cutoff. That's also set to 4 on the neural signal processor, so I'll leave it as it is. But I do want to adjust my cutoff frequency a bit, and I have a few different ways of doing that. First off, I could simply type it into my options window. I can also adjust it on my frequency spectrum. We'll leave it there for now and move on to some of the other options that we have available. So within the filter section, we also have the option to use filter energy or signal energy. If we choose to use signal energy, we'll be presented with a couple of additional plots related to signal energy, such as a signal energy over time down on the timeline, and a waveform energy histogram, which is part of Kite's histogram plot. Within signal energy, we have a few different options, including the type of signal energy we would like, as well as the window width, which is sort of a boxcar look at measuring signal energy. We're just going to keep this simple for now and stick with the standard high-pass filter. So let's uncheck signal energy. After we have our filters set up and they look good, we can move on to the next most important step, or the next step in the process, which is thresholding. Thresholding, as the name suggests, is a threshold that a signal must cross to be extracted as a spike. So by default, BOSS starts with a single threshold, and the single threshold can be adjusted in a few different ways. Just like the cutoff frequency, we can adjust it here on the options window using the arrows or typing it in. We can also adjust it on the timeline, which I prefer because it's kind of a visual method of looking at the threshold. Alternatively, you can adjust it on the peak height histogram. And you can see as we adjust it on any window, there's a value next to this called ADC counts, basically analog digital converter counts. BlackRock's 16 bits combined with our analog input range give us an ADC basically conversion of 0.25 microvolts per digital value. And that's what ADC counts is measuring here. Most people would probably prefer to think about their threshold in microvolts, which is why we prioritize it. We have a few other options in thresholding. So again, by default, BOS starts with a single threshold, but we have the option of selecting dual thresholds as well. Dual thresholds can come in handy when you have spikes that are maybe less symmetrical across the axis, such as ones that are primarily positive or primarily negative deflections. And in this way, using a dual threshold, you can make sure to capture both of these spike types. Dual thresholds can be adjusted independently of each other, unless you check the symmetrical checkbox, in which case they will always be symmetrical along the axis, like a mirror image. Another option available here, but it's grayed out because we haven't checked the box up above, is the option to threshold on signal energy. So of course, if we choose signal energy up in our filters, we would want to threshold off signal energy, which is an option you have here. And finally, there is an option for proportional to noise RMS. And what this means is that we can have BOS set our threshold based on a multiplier of an RMS of the noise. So basically, BOS will look at that noise band that we have there and attempt to set a threshold that's some sort of multiplier of that. Generally, I feel that ranges somewhere between 3 and 6 are useful for this value. But let's just keep it simple again and stick with our single-sided threshold here. The very last option we have, of course, is adjusting what actually an extracted spike looks like. So we have 3 primary options here. We have the length of the spike. By default, it's set to 48 samples, which in our 30 kilosample per second data is about 1.6 milliseconds. And it's the same default setting as our neural signal processor, so we'll leave that as it is. You can also set the pre-threshold period, or in other words, how many samples appear before your threshold crossing and how many samples appear after your threshold crossing of those 48 samples. We'll leave that at 24. And finally, a number that you might find yourself adjusting more often than those other 2 is the refractory period, or in other words, how long you have to wait between threshold crossings before you can have another one. And we'll leave that at its default setting as well. But like many of the options above, you could adjust any of these on the options window using the little arrows or by typing in the value. So now that everything is kind of set up and ready to go, we could click the detect button at this point. But before we do so, I kind of want to give you an idea of what's going to happen when we do. So BOS makes use, or excellent use rather, of kind of multi-processor technology. So this enables BOS to kind of spin off processing tasks into other threads so that it can continue chipping away at a file or chipping away at a process while you continue working. So in the case of a very, very large file, it might take some time to process or detect spikes on channel 1. So I could set up my detection to start running, and then I could move on to channel 2 and begin setting up my detection there as well, with no performance loss on the front end. So I'm going to try to give you a preview of that right now by clicking detect. We'll see that the channels, the highlighted channel in my channels panel will begin flashing to show us that we're processing. And I'll show you how we can move over to channel 2 while that's happening. So if I click detect, I didn't quite make it because it was a bit too fast. But if channel 1 did keep processing, we could begin work on channel 2 while channel 1 was processing. But if we look back at the detect button, we can see over to the left that we detected 3,789 waveforms, which is just an overview of how many we extracted from the file. With our waveforms detected, we can move on to the next step, of the BOSS spike sorting process, which is, of course, sorting. Now that we've click detected, we can see that the sorting option is not disabled any longer, and so we can now click on it and move to this screen. If you had loaded a spike data file instead of a continuous data file, this is the screen that you would start on. And sort would be the only kind of option you'd be presented with. You wouldn't have to look back at the detect step for a spike sorting file that just had spikes. So in this sorting step, we have a few new windows and new options that we can look at. Like I mentioned to you before, some of our same panels will stay around, such as the options window, the timeline view down at the bottom, and the channels view over on the right. In addition to those, we now have a bunch of new windows, though, such as the feature versus feature plot that we're presented with here, 3D clusters, 2D clusters, our waveforms view, and a units view. Again, BOSS is very easy to move around panels and resize things. I've already set this up for myself, actually, and set up so that all of the kind of cluster views are nested on top of each other, and all of the kind of unit waveform views are nested on top of each other, because this is the type of layout that I prefer. So with an understanding of our new views, we can go ahead and move back to our options window, which will kind of guide us through the spike sorting process. So the first kind of set of instructions or set of options we're presented with are the features. So the thing that's most obvious is this large matrix, which shows a number of feature pairings that we can choose. So we have a list of features, and it's a two-dimensional matrix, and we can choose any of these options. And the options that we do choose are shown in our feature versus feature plot. Now, by default, BOSS selects 4 specific features, and it selects these based on their clustering tendency, which is an algorithm that we can talk about a little bit more during the Q&A at the end of the session. But this clustering tendency is color-coded on this axis, this poor to good clustering tendency legend that you can see at the top. So we can see here that BOSS has selected the 4 feature pairings that give us the best clustering tendency. And if we look over into our feature versus feature plot, all of those do look pretty good as far as the kind of clear clusters they're giving us. If we wanted to look at additional feature pairings, we can always just add them to the window by clicking on them here. Or if we want to look at less of them, we can deselect them as well. With the features that we want to use to kind of analyze our data and look at the sorting, we can move down into the actual sorting steps. So BOSS has a bunch of sorting options that range from pretty much completely automatic to completely manual and everywhere in between. 2 of the kind of more automated methods are shown here in the sorting step down at the bottom of the options window. So we have t-distribution, expectation maximization, and k-means. Since most of us are probably more familiar with k-means, we'll go ahead and stick with that one for this sorting session. K-means is a recursive algorithm that attempts to repeatedly recalculate centroid positions until it reaches a convergence point where the centroids are basically static. And this means that we can do a more automated sort on it and have k-means attempt to identify the centroid positions itself, or we can actually help k-means out a bit and make it a bit less automated by defining some of the centroid positions. So we're going to go ahead and try both of those methods just so you can see how they both work before we do some manual editing to clean up the results. So I could at this point just click sort, and I'm going to go ahead and do that. But first I want to make sure that I've adjusted my clusters, that I'm kind of guessing how many there are. Since our feature versus feature plots are very clear and we're working in simulated data, this is extremely clear. So I can set clusters to 3 and click sort on k-means and expect a pretty good result. And if we do this, we can see that k-means has sorted the clusters into 3 separate units that definitely fit those 3 clusters. Now, if we wanted to make this algorithm a bit less automatic and give ourselves a little more control, or give k-means a starting position, we can click on define. And you'll notice that when I click define, I'm redirected to my 3D clusters window over on the right. And this is because this window is where we define our centroid positions. And all I need to do then is to hold down Control and select a spike that I feel is the center of each of these clusters. So after marking 3 clusters, I can again click Sort, and we can get a result that is pretty similar to what we saw before. Now, automated sorting methods are great, and k-means is a good algorithm, but typically we'll want to go through and do some manual editing and cleaning up of the data anyway. So that's what we're going to jump into now. Since we won't need the options window to do this, I can go ahead and just get it out of the way to give ourselves a bit more room to work with these spikes. I'm also going to bump up my point size so that I can recognize points that might be kind of stray or noise waveforms that are outside of my clusters. So again, we can see here that all of the spikes are colorized in every view that they appear in. So it's clear what my units are, what they look like. And if I look at my units view, I can see what each of the kind of average waveforms looks like. And at this point, I mean, looking at the waveforms view, it's pretty obvious that we have some clusters or some waveforms that don't really fit into our units. They might be noise or they might be shifted. And so what we can do is we could either attempt to align those with this align method here at the top of the waveforms view, or we could get rid of them as noise. Since there's so few of them and our clusters already look so good, let's practice getting rid of some noise. In my 3D clusters view, I can see these kind of errant spikes down in the bottom right corner. And if I move into editing mode in 3D clusters, I can actually just circle these spikes to select them. And so I can see that they're selected here in 3D clusters, and they were selected over in waveforms. And if I right-click on any of these windows, it gives me a few options for what I can do with these selected spikes. So for example, I could choose to make them unsorted. I could also move them to a different unit by highlighting Unit 1 or Unit 2 and clicking on them. I could, if I wanted to, add these to a new unit. So I might consider that these might be a different unit of spikes. But I'm going to go ahead and mark these as noise. And so the invalidation option will basically just remove these from our data set, say that they're noise, and not display them to us anymore so that we don't have to worry about them. I can see that I missed one here, which is kind of in the upper right of my PCA space, it looks like. And I can highlight that one and perform the same option. So with our spikes cleaned up a bit, we can actually go ahead and just kind of double check our work. We can look at the other views, make sure there's no noise units that are hanging off the edge or outside of our clusters. And we can hide some of our spikes here in the waveforms view just to make sure that everything looks good. And it does. And so we can probably end our editing of channel 1 here. Now at this point I have a few different options. I could choose to save this file as a new NEV file or CSV or mat.mat. But I'm actually not finished sorting my whole file here. I have many other channels that I would like to sort on. And so at this point, I plan to just quit BOSS. And if I do that, it's not a problem because BOSS will actually automatically save my work. So anytime I quit the program, it will save everything right where I left it. And when I start the program back up, I can start right from where I left off before. This is great because if you're somebody who might work on a file over multiple sessions, maybe it's a really large file, or maybe really intensive sorting, then it's very useful for being able to split up your work. And it just helps to ensure also that you don't end up losing any work at all. I've had my laptop die on me while doing spike sorting before, and BOSS will have saved some session data in the background, which is definitely useful. This has really happened. So with that, we can jump back into our presentation and take some time to answer some of the more popular questions that we've seen pop up in chat, and give you all some more time to ask any questions that you have at this point. So for any of you that missed it before, either in the registration or in some of our talk earlier, you can download the BOSS software at www.blackrockmicro.com/boss. And we want to encourage you at this time to ask any questions that you have in chat about the software or anything else really at all. And if, as you probably will, if you think of any questions after you leave chat today, please feel free to email them to support@blackrockmicro.com. So with that, let's go ahead and take some time to answer some of the more popular questions that have popped up.
Actually, there was a couple of questions that everyone is probably interested in learning. One was where to get data for you if you don't have any data. That's also when you go to blackrockmicro.com/boss, you'll be able to download the Windows, Mac version of it, and also the manual along with both NS5, an NS5 continuous data, and a net file. And you can load both of them into the program. When you load a continuous file, of course, you have to then first set the threshold and extract the spikes. When you load a net file, that step is skipped because you already have spikes. And there was also another question on the price. For a 1-seat license, it's $19.50, and for a 3-seat license, it's $39.50. However, there is a 25% discount until the end of March, or if we sell the first 100 licenses, so whichever comes first.
Thank you, Kian. And to remind everybody, those links that Kian just sent, the blackrockmicro.com boss links, are version 1.1 of the software, which is a recent release. And BOSS is constantly being updated, so keep in touch to receive all of the newest updates on BOSS. If you buy a license, all version 1.x versions will be free of charge, of course. So one of the questions that we just got was, what is the largest file it can analyze? So we actually did cover this a little bit earlier, but just to go over it again, BOSS doesn't have any limits on file size. So as Kian mentioned, the only limit is your hard drive size. So BOSS has a very intelligent series of algorithms to be able to analyze large files and split up the work and be able to do a lot of the processing in the background, which is a useful feature, so that you don't have to take the time to split your files beforehand or break up your large recording sessions into tons of little bits.
There's
another question that has come up is the kind of question of sorting a continuous data file from a session in which you're recording other experimental data. So for those of you that are fairly familiar with the kind of BlackRock system and how things work, you end up with two kind of primary data files, your continuous data and your neural event data, which includes things like experimental triggers and comments and digital inputs. And these are all things that you might want to maintain in your sorted spike data after you extract spikes from a continuous file. And so to answer kind of this user's question, if you extract spike data from a continuous data file, BOSS will automatically attempt to find the neural event file for that session and put that sorted data in that neural event file. So now you have your sorted data and all of your experimental event data in the same file.
There's also a question on compatibility on which operating system. The question was, does it run on Linux? Yes, it runs on Mac, Windows, and also Linux. On the link on the website, there is not a Linux version, but we'll be adding that soon.
Very good.
Nick, there was also a question on batch processing on channels. So if Silvana or you want to comment on that, and how do you batch process mini files? Whether you have small files that are the size of a single trial of a few seconds, or you have mini files that you've recorded over many days.
So Boss does not currently have this feature, but it's going to be released in version 1.2, which is planned to be released in the next 2 to 3 months. And just to remind you, anybody who downloads Boss 1.1 or purchases Boss 1.1 would get a free upgrade to this version 1.2 when it's released here in a few months. A kind of similar question to that, somewhat similar at least, is we had a user ask whether they say they repeat the same experiment many times. So they actually segment their trials into little like small data segments. And so therefore they have several files that have basically the same channel definitions and are recorded seconds apart from each other. And so a question they had was whether they could combine and sort all of these together. So it's kind of like batch processing, but instead of doing them sequentially, it's all at once. And similar to the batch processing feature, Boss doesn't currently have this, but this is also planned to be released with version 1.2, which again releases here in a couple months.
There's also a question on file types. So currently it supports BlackRock files only. Very soon, and maybe Nick can comment on the timeline, it will also support the Plexon files. And then we are going to add features, the different file type formats to it very soon, as it's just a matter of time and how quickly we can add it. But it will eventually support TDT, Neuralink, CED, and so on. If you have any special requests, please do send them.
So Kian, Boss does actually currently support PL2 files in the 1.1 version that was released today.
Oh, even better. Things happen very quickly, Nick.
We're innovating so quickly, Kian can't even keep up. He's been traveling out of the loop.
And someone asked if there's a demo. As we mentioned before, if you go to blackrock.com/boss, BOSS, that's where you can download the demo file again, and along with sample files that you can analyze. Also, there are some questions on people who are having issues with installing it on your software. Please send an email to support@blackrockmicro.com. That will create a ticket, and then we'll work with you on finding out some of these issues. Nick, there's also another question, maybe you or Silvana. What does the clustering tendency grid indicate? What is the calculation behind it?
So the clustering grid, it's an algorithm that attempts to indicate whether there are clusters in the data and looks at how well separated they are. So it kind of looks for separation between clumps of points. And so what you get after performing this calculation is a coefficient from 0 to 1. And that 0 to 1 is kind of the percentage darkness of each of those cells that we saw in the matrix. This is actually an algorithm, or this algorithm was developed at Georgia Southern University. And for anybody who's curious, we could actually send you a link to the paper. And if you end up wanting that paper link, well, the title is an algorithm for clustering tendency assessment. but you could always just email support@blackrockmicro.com and we'd be happy to send it over to you. Or you could potentially ask in chat.
There's also a question on whether is it necessary to repeat the demonstrated sorting process on each channel? Is there a way to sort all channels at once?
That's another feature coming soon as well, along with the batch processing. Kind of all along the same line of thought. Processing multiple channels at once, processing multiple files at once, or processing files sequentially are all something that's coming soon in version 1.2 in the next 3 months or so.
The other question is, will it be able to work with EDF files?
EDF?
Yes.
Oh,
It's a European data file format.
European data file format. That's not one that's currently on our list to be developed for right away. But you could always look for a file converter to put it to a more to a different file format and load that into BOS as an option.
Another question is, will it be able to export data about timestamps, events, and waveforms to MATLAB?
Yes, so one of the export options we listed were .mat files. So we can do a .nev, .mat, or a .csv. And .next for NeuralExplorer.
The question is, can it process NEV files? So can
Yeah, of course. BOS can open neural event files from BlackRock and load all of the spike data. So like I mentioned kind of during the software demonstration, if you loaded a spike data file, such as a .nev, you would end up at the sorting screen. And that would be your kind of launching off point, and you'd begin sorting from there.
Is there support for tetrode mode, tetrode files, electrodes?
So that one was actually answered publicly in chat. But that one is also coming soon. That one will actually be prioritized slightly after some of these batch processing features. So that one is not slated for release in 2 to 3 months, but is more on the timeline of maybe 6 months out.
Okay. Could you also elaborate on the publish option a little bit more and explain that?
Yeah. So the publish option is basically the ability to export to like figures to PDF files. And so the publish option will be something that's available in the future. I mean, it's not the 1.2 version, so not 2 to 3 months, but sometime past that.
Another question is, does it import online sorting?
Yeah, I mean, depending on, if I understand that question correctly, a lot of users might do online sorting of their data so that they can trigger off certain units, or just to kind of get a head start on sorting the data when they load it into an offline sorter. And BOS can definitely accept those types of files. BOS does not accept currently live data from the neural signal processor. And there's another question in chat. Is it possible to detect other types of spikes, such as EEG or heartbeats? Yes, this is all possible with BOS. Detecting kind of the cardiac waveforms is something that BOS is capable of. You would obviously want to adjust your spike width to be wider, since those waveforms are going to be a bit wider than high-frequency neural spikes. But yeah, BOS could definitely be used as this type of option.
Nick, the question is, how do we merge two different units that were identified as separate, but they're visually looking to be the same spike? How do you do that? Is it possible?
So as the answer in chat appeared very easily, basically all you need to do that is highlight the waveforms that you think should be part of the merged unit, and then you can just click the drop down to actually select or put them into the other unit, basically, or combine them. So for example, here on the screen, I can highlight my pink waveforms, magenta, and I can click on any one of my other two units, and they will be labeled as that unit. Now in this case, they're clearly separate units, so it doesn't make a lot of sense, but the workflow is still the same. Similarly, if you have two units that are merged, like I just did here, you can always highlight them and then click Add a New Unit to break it off into a new one. You can also do this from the unit view by right-clicking on the unit view and clicking Combine with another unit. Whichever one is easiest for you.
Thanks, Nick. The other question is, what happens if the amplitude of a spike changes over time throughout the recording session? How does BOSS handle that?
So for changing amplitude of spikes, oftentimes that can be cleaned up a bit manually. So by moving through your file, the timeline view will actually show you segments of the file at a time. And so you can watch your unit move a bit and continuously kind of re-identify it is one option for dealing with kind of changing amplitude in spikes, or at least a common method that I've seen. And I usually like to do this also just to ensure that I am kind of being accurate and double checking my work anyway.
I have another question whenever you're ready.
So there's a question here that says, is it possible to use MATLAB to export old data into BlackRock format that BOSS can use? So this is definitely possible. For those of you who don't have the toolkit already, we have something called the Neural Processing MATLAB Kit. And what this kit does, or what it is a kind of series of scripts and functions that allow you to load BlackRock data into MATLAB. You can convert it or downsample it or change it or subsection it into pieces, and you can export that back into NEV files or NS5 files or other data formats such as headerless data files or like .dat files. And so that can be used to convert basically old file types such as a BlackRock file format 2.2 into a BlackRock file format 2.3 pretty easily.
Nick, also the question is, can we get an inter-spike interval distribution plot for one of the sorted units within BOSS?
So that's not a feature available right now, but it has been a popular request, and so that's something that we plan on implementing sometime in the next 3 to 4 months. And so for another question came up about what type of licensing options we offer. I think Keon mentioned a single seat license, but we also do a 3-seat option, which kind of comes with its own built-in discount per seat for people who have multiple users in a lab. Additionally, just so everybody knows, this licensing is powered by a licensing dongle, which is actually very useful because it lets you easily take the dongle out of one computer and put it into another so that you can kind of spike sort on the go, if you will. So, for example, I might take a dongle out of my computer in my lab and put it into my laptop because I just love spike sorting home on the couch at night.
There's another question that says, are there any tools planned for automatic single unit, multi-unit distinction?
Cross parallelograms. So looking at the difference, so auto detection of single unit and multi-unit activity, like waveforms, essentially. Is that what you're asking?
I don't know. I think to be able to distinguish between whether an activity is a clear single unit or multi-unit activity. This came from Michael, so if you could clarify this. So he will clarify, but let's move to another question. The question says, can BOSS handle non-stationary thresholds? So, for example, in an hour of recording, the baseline noise drifts, and does the threshold, can I adjust the threshold for different points in time? So when you have a long data file, can you set thresholds for different segments separately?
Yeah, so actually the RMS set threshold based on RMS of the noise earlier that we talked about. I can actually go back to it here. This is set per chunk of the data file. So you can see me move along my continuous timeline here. And that RMS is calculated per chunk. So that will actually automatically adapt to the baseline noise level for each chunk of the file. So to answer the question, the answer is yes. BOSS will automatically adjust threshold for the along the length of the file if you select the proportional to noise RMS. A single threshold is a hard line and won't adjust during the file.
Thank you. And somebody asked about the double scrolling and why you have two different scroll bars on the detect window. So I guess you kind of did explain it. So you see, yeah, that's one scroll, and there's another scroll on the bottom.
So the scroll at the bottom is just showing my position within that chunk. So I've zoomed into this this chunk of the file, and so the one at the bottom is just showing me kind of where I am within that chunk, whereas the one at the top is my navigation through the file as a whole. We have another question here. Are there any yearly maintenance or service fees after purchasing the license? As with all BlackRock products, we offer effectively unlimited support with the purchase of the product, so you can always email or call in to support@blackrockmicro.com, and we'll be happy to help you out. And as the answer in chat also mentioned, you would, to get the newest version of BOSS, though, when version 2.0 comes out, you would need to end up paying an upgrade fee at that time.
And also, could you, the question was, can you adjust the timeline window width or any of these window widths, what you just did? Can you even make it even wider by, I guess, undocking it and moving it?
So you just mean like extend the timeline so that it...
Yes, okay, yeah, that's...
Yeah, so you can pull the timeline out, I can move it to a different monitor, and I could make it basically as big as I wanted. So I could just pull it out here, for example, and look at it really large.
Mm-hmm. Thanks, Nick. Another good question is that, you know, I record both NEV and NSX files at the same time, obviously. And then offline, I want to be able to load my continuous file do re-thresholding and do sorting, but also my NEF file contains important information like tracking all the digital I/O inputs. How do I, if I save the sorted NSX file, it will create a new NEF file, and I'll lose my data from the other my NEF file. How do you fix that? How do you combine them?
So this is actually one we answered earlier by voice, but to answer it again, basically after you load and detect on and sort a continuous data file, when you go to save your file to an NEV file, BOSS will automatically look for NEV files with the same name, since our data is saved that way. And if it finds one, it will ask you if you want to take your sorted units and put them into that NEV file that contains all of your digital inputs and comments and things like that. So very easily, BOSS will just detect the file and will attempt to merge them for you so that you can make sure that all of your important experimental information is saved with your sorted units.
Thank you. And there are some questions on performance on Mac. The question is, are you sure that it supports multi-cores because only one CPU is running really high in the viewer? I suggest that if you have this issue, please email us at support@blackrockmicro.com, and we'll get together with you to see what the problem is. And this could potentially be a bug or something that goes on.
Okay, I think we've answered the majority of the questions. I'm sure many of you will think of questions that you have about BOSS, or as you begin using the demo version, you might come up with questions. And so if anything like that comes up, do not hesitate to email support@blackrockmicro.com, and we'd be happy to help you out.
Nick, there's one last question.
Okay.
Can you reference in BOSS?
So you want to set up a software reference within BOSS?
Yeah.
That is not currently an option, no. You can always re-reference your data, BlackRock data with something like nplay server before you process it with BOSS.
Or even in, you can do that in MATLAB as well, and then reset the data into NSX. There's some good questions coming up. Sorry. The question was, can you add autocorrelogram feature to sorting? I have a hard time with this word. And the answer is basically yes. It's already there in version 1.1. If you happen to download the older version before, there was a new version released today. So just go to blackrockmicro.com/boss to download the new version. And another question says, is there an upper limit to the number of units that can be sorted? Yes, but it's 255 units. Hopefully that should be more than plenty.
255 per channel.
Per channel, yes. And that's it.
So again, thank you all for joining us. I'm going to go ahead and sign off so that Yulia can thank you all for coming. But thank you for all the questions. And again, if you have any more, do not hesitate to get in contact.
Thanks a lot to everyone for joining us today. Have a great day or evening, depending on where you are. And please let us know if you have any questions on BOSS.